And our next speaker is Teresa Valor, and she will tell us about prescribed burning effects on Mediterranean pine growth. Please have the floor.
Yeah. Well, thanks for coming to this presentation. Well, I'm going to talk about how prescribed burning affects pine growth. And in the second part of the presentation, I will talk a little bit about how fire can affect terpene storage or chemical defense production. So let's begin with tree growth. Well, fire can affect negatively tree growth because it can damage the cambium, the root, and also the crown. But it can have also positive effects because it can increase light, soil, and water availability. But both the direct effects and also the indirect effects of fire on tree growth will depend on the size of the tree, the time since burning, the species, and also the burning season. So I'm going to show data of several dendroecological studies to try to explain the factors I mentioned above and how they affect tree growth. So we have used 3 species with contrasting tolerance to surface fire: Pinus alepensis, Pinus sylvestris, and Pinus nigra, being Pinus nigra the most fire-resistant species. So here you have the effect of crown status and time since burning on tree growth. And we have, you can see the growth for the first 4 years since burning for each species. And all the growths that are above this line, it means that trees are growing more than expected without fire. So I will refer to this growth as a positive growth. And below the line, this line, it means that trees are growing less than expected without fire. So I will refer to those as a negative growth. So in the thick line is for dominant trees, and thin line is for dominated trees. So first of all, you can see that dominant trees are growing more than dominated trees. And if we look at Pinus alepensis, both dominant and dominated trees present negative growths the year of the burn. But as time since burning increases, dominant trees presented positive growths. In the case of Pinus sylvestris, dominated trees presented negative growths, and dominant trees presented similar growth similar growths. But as time since burning increases, the tendency is to present negative growths. If we look to Pinus nigra, the year of the burn, the growth was positive, so this tree was growing more than expected without fire, and dominated trees show negative growth. But as time since burning increased, dominant trees presented positive growth during the whole period. Well, these results are from burns that were executed in 2002, 2006, and the tree ring sampling was done in 2011. So we didn't have data on fire behavior or the proportion of the crown scorch. So we used ball scorch heights as a proxy. So what we found in the case of Pinus nigra is that those pines that had higher ball scorch height presented higher growths, and not only for dominant trees, but also for dominated trees. Well, the results I have shown so far are from burns that were executed with the objective of only reducing surface field load. But we previously found that small Pinus nigra that survived to a big forest fire that occurred in Catalonia in 1994, with ball scorch heights greater than 3 meters, reduced growth the year of the fire, this solid line here. But as time-seize burning increased, they were growing more than control trees. But in this case, these trees were growing in plots where there was a significant reduction in tree competition due to created by the fire. So with this information, in 2013, we conduct a series of experimental fires of high intensity to try to create tree mortality. And we wanted to test the effect of crown scorch and also the effect of burning season on tree growth. So here we have data on the effect of burning season for Pinus nigra. In blue, you have control trees. In red, you have trees that were burned in fall. And in green, trees that were burned in the spring. These trees didn't have the crown damage, okay? So you can see that for the three chronologies, there is a good synchrony until it arrived the year after the burn, where fall trees that were burned in fall and in spring were growing more than those that were unburned. But this is preliminary data, but it says something like that. But there is no effect of the burning season, because it seems that fall and spring trees are growing pretty much similar. In the case of Pinus sylvestris, you can see that the year after the burn, fall trees that were burned in fall and in spring were growing less than control trees. But again, there is no difference between those trees that were burned in spring and those that were burned in fall. Here, I'm showing data of the effect of crown scorch on tree growth for Pinus alepensis. And in green, you have trees that were not burned. In black, trees that were burned, but the crown was unscorched. And in red, trees that presented between 40 and 90% of the crown scorched. So here you can see that there is a good synchrony between the chronologies. And then the year after the burning, the scorched trees reduced growth in comparison with control and unscorched trees. And this is probably because the photosynthesis was affected, but it could also be that these trees were investing in chemical defenses because they were actually quite damaged. So in conifers, the main biosynthesized secondary metabolites are terpenes and phenols. And oleoresin, which is a star in the resin Dutch of wood and needles, is composed by a mixture of monoterpenes, sesquiterpenes, and diterpenes, which have different degrees of volatility. And in general, they confer protection against pathogens and also against thermal stress. So we ask whether terpene content in needles is favored by fire over time, and if pines with contrasting tolerance to surface fire differ in their response. So here we have data on monoterpene content for the three species, and we have data before burning, 24 hours post-burning, and 1 year post-burning. And what we see is that the lower fire-resistant species seems to have higher content than before burning, 24 hours post-burning, or similar content in the case of Pinus sylvestris. And if you look to this graph here on the right, you can see the relative content change of monoterpenes and all the 24 hours post-burning. So the contents that are above these lines, it means that trees have higher content than before burning. And if you plot this against crown scorch, you can see that as crown scorch increases, the content in terpenes, in monoterpenes, also increases. If we look to diterpene content, here, before burning and 24 hours post-burning, there is no differences. But 1 year post-burning, there is a decrease, a significant decrease in the content of diterpenes and also in monoterpenes. So we measure carbon-13 in the needles. This is a proxy of the water stress, and we measure it before burning and also 1 year post-burning. So the change in carbon-13 here is plotted against deterpents, and what we observe is that those trees that were less stressed 1 year post-burning, because fire induced probably a reduction in tree competition, had lower deterpent content. And the same happens with nitrogen. Those trees that had higher concentration in nitrogen also presented lower terpene content. So to sum up, we use crown scores as an indicator of tree size. And dominant trees respond better to fire in terms of growth than dominated trees. This is probably because they have thicker barks. And in relation to burning season, I have shown only rough data, so we haven't done any statistical analysis, but it seems that it doesn't have an effect, at least in growth. In tree mortality, we have a poster, and it seems to interact with fire severity variables, so if you want to see it, it's quite interesting. In the case of crown scourge, it seems that those trees that are damaged are the short term after burning are investing more in chemical defenses than in growth. And as time since burning increases, this effect is still visible. Then if we look to resource availability, those trees that benefit from a reduction in tree competition induced by fire, they seem to invest more in growing than in defense, basically. And lastly, if in relation to the species, short term after burning, the lower fire-resistant species seems to invest more in defense than in primary metabolism. And in Pinus nigra, which is the most resistant species, seems to invest more in growing than in defense for the same degree of fire severity. And as time since burning increases, it seems that Pinus nigra and Pinus alepensis are responding better than Pinus sylvestris. But the three species seems to reduce their content in terpenes, so this is probably saying that they are more vulnerable to pathogens. But at the same time, it could be also mean that they are less flammable because terpenes are also very related with flammability. So there is a lot of questions still to answer, but thank you very much. And yeah, that's it.
Thank you, Teresa. So we have time for questions. So no, I have a question. Where do you quantify the terpenes? Where? In the bark? In the
needles. I think I say it, but
in the needles.
In the needles, yes.
Okay. And what method do you use?
Gas spectrometry.
Okay. Thank you. So, thank you, Teresa.